All right, we're going to talk about programming. We're not going to cover any language in great depth, but we will cover some of it. Okay. So computer programmers must understand rules of programming languages. I was actually answering a discussion today, and I'm currently teaching the C++ class at the same time. And the student mentioned how he liked learning the different syntax of the different languages. And I'm going to tell you a funny story that kind of relates to this. I took Virginia on a cruise to Spain. He left out of Spain. So naturally, she was very worried about not being able to speak Spanish. If you know anything about, anyone ever been to Spain? Most of them speak English anyway.
Everybody speaks.
Pretty much everybody. So she was so worried about, oh my God, I don't know anything. Then she likes drinking beer, so I taught her, dos cervezas, por favor. No, just 2 beers, please. So she practiced it and practiced. She was all ready to order her 2 beers. So she goes in, we went to some restaurant, she ordered 2 beers. What do you like, Michelob or Bud? They replied in English. She's like, well, that sucks. So, but the point is, learning a computer is just like learning another spoken language. It's really just the syntax. It's just the words, okay? Deal with syntax errors. I teach programming all the time. I get so many people. It's like in Java, you need a semicolon at the end of every statement. So when you go to compile, it tells you something wrong with the statement. That's the first thing you should check for. But so many people don't look for minor stuff like
that. A lot of compilers will tell you, hey, there's usually a semicolon.
Exactly. They tell you what it is. It's like you're not even looking at the errors. Like people send me something, I can't get this to work, so I'll run it. Oh, line 42. Okay, you fix that. Oh, line 18. You fix that. Oh, there you go. It's fixed. I'm like, the compilers literally tell you what to do. Okay, so one minor mistake, the program will not run. That's true. Not always. Sometimes they will run. Okay, I said sometimes they'll give you unpredicted results, which is actually a big problem. Okay, being a good programmer takes time, patience, and you have to like spending a lot of time alone. I'll tell you, when I rewrote my John the Ripper script, I guess it was not last Thanksgiving, it was the Thanksgiving before, I spent basically the entire week working on it. And the problem was it would literally take a day to run. So I had to run it to make sure everything was working correctly, and didn't run. I had to go into modify it and take another day. But it takes time, it takes patience, but it makes you think differently, what I like. Because you can be writing programs with little knowledge. They talk about branching, looping, and testing. I'm assuming all of you have had some sort of scripting language class, since it's kind of required. Okay. And by the way, if you ever want to make a BLT that's the best in the world, skip the lettuce and put on peeled cucumbers. Oh, trust me, night and day difference. You'll try that and you will never eat a regular one again. I'm just saying. So remember that. No lettuce, put on peeled cucumbers. Like what? Because it gives it that, oh, it's just good. So go make one and bring it here. Okay. Yeah. Functions. So the function in program is a mini program that produces or within a main program. You have a main program that calls other separate modules or functions, whatever they call them here. Okay. Branching, maybe you can make it do different things. If this, then that, go do something else. Looping, continue until someone hits Q, or until, in my case, until the darn program finished, which was 24 hours later. Testing it. Testing is a big deal. Testing is where I think a lot of my problem is, because you test it, but are you testing every possibility? So a lot of times we don't. We don't test everything. Okay? All right, what language do we got here? Anybody?
Let's see.
Let's see. Yeah, it's definitely Java, but it's Java.
JavaScript.
Well, no, it's not. No, it's neither, because there's no semicolon after the second get out. It looks like Java except for the missing semicolon.
Oh, the second get out is the declaration of the get out method.
Oh, duh. So it is C then. Okay, it's C then.
How come
No.
there's a void in front of the main?
Well,
is it returning something?
Well, if it was returning something, it would say.
No, in C++,
Yeah,
it's not
you really normally have an int in front of it. So we don't know what the heck this is. It's not complete, whatever it is.
I think it's pseudocode.
It's kind of in the middle of multiple languages. Okay.
It's something.
But in this case, you'll notice this if up here. This if is kind of the branching thing. You know, we're going to test, we're going to do it if something meets something, or else we're going to do something else. And here's our loop down here. We're going to continue as long as A is less than 11. So then this over here, this is an incrementer, also called unary operator. So A is going to be 1. We're going to check it. Is A less than 11? Yes, good. I'm in the get out function. Then increment A to 2, 3, 4, so on and so forth. Okay. Algorithm is basically, as I said, a defining steps to perform a task. It's thinking about it ahead of time. Keep it as simple as possible, but it needs to do everything you need to do. A bug is an error, and pseudocode is English-like language, kind of like that one was, but not quite as programmy. English-like language used to create program from it. See, the problem with this one is not really so much pseudocode because it's mainly like Java or C, so actually it's neither one. It's not complete.
It looks almost like JavaScript.
Yeah, it would still need semicolons.
No, not in the latest one.
Yeah, but you need one up here. This would need one.
No, they got rid of that one.
And this variable is not even a complete. This is not even a complete comment. We're missing the slash at the end.
There is something weird going on, whatever.
Yeah, whatever it is.
not really
It's
like-
not complete.
Every time they do a comment, they do it differently.
Yeah, it's
There's like
weird.
4 different ways.
Okay. Documenting your work is essential. Okay, funny story. I got a call today from Kyle Cook. Kyle Cook used to work up in our lab upstairs, and then he went to the NSA, and now excellent. You never meet a better programmer. But Kyle wrote some code for Air Inc. Air Inc. is off of Air Depot and 59th, just south of the base. He wrote some code for them. Then he left, and then Frank, another fire supervisor, got a job there and was working on Kyle's code. And he got to this one module and couldn't figure out what the heck it did. So he called Kyle, and he's like, hey, what does this module do? And Kyle starts dying laughing because he said he tried to write the module in the most cryptic way possible so no one would ever be able to figure out what it did. That's exactly what he said. He goes, oh, you found it. It was, you know how hard it was to no one could figure it out? Not good programming practice, by the way.
Funny though.
Yes, it was funny. But when I worked in the ARM, it's the Aircraft Radar Maintenance Training Set on Tinker, and I was an RMX programmer. We used Pascal 286 and RMX. I know you probably never heard of that. But the way that language worked was very weird. But we worked on a simulator for the military that the military had hired out. They hired a company to write the software for them. They spent like $20 million on it. Then the company kept coming back. It's not done. It's not done. And finally, the government just canceled the contract. So the contractor just threw the stuff away. So the government bought it for $1 million, that stuff they didn't want. And then military people, in other words, me and other people, we got it working. But we took what they had, which wasn't quite complete, had to fix it and modify it and make it do different things. But there was this one file, we never knew what it did. So at the very top of the file, someone put a comment that says, don't change this file, don't delete it, just without this file. Because it basically was a touch screen. It was a touch screen. They used a video laser disc that would simulate the radar on an AWACS.
So you had a file that you didn't know what it did,
Right.
but without it, it didn't work.
Exactly. That's exactly what it was. Because if you took the file, we never did figure out what the heck that file did. And then, the military is real big on DUIs. But we have this one captain who had gotten more than one DUI, but was still in the military, which is not a normal thing. But what was funny, this captain came over one day right before I was getting ready to retire and looked. He literally just looked around the system. It's a special piece of hardware made by IBM to run it and everything. He literally just looked and left. I retired. And shortly after that, he came over with a floppy disk at the time. Said, here you go. And it was the entire driver set to make the entire program work on an IBM PC. And it worked. Literally just by looking at it, he went back and wrote the drivers, everything needed to get rid of the entire IRMX system, run off a Windows PC, and it worked. I was like, holy crap. So that's why he was still in the military with multiple DUIs. But he was good. Yes, but the point is, it's really important to document your code. Just because you know what you're doing today doesn't mean you know what you're doing. You know, I wrote that John the Ripper program 2 years ago now, or a year and a half. I don't remember what the heck I did. I have to go back and spend time figuring out. Look, I put some comments in it. So add comments to your code, explain what you're doing. It says many programs find it time-consuming and tedious, but it helps you understand what you're doing. It helps other people. Because what's the odds you're going to be working on it forever? Very slim. Okay. Industry standard, 10 bugs for every 1,000 lines of code. That's what they're saying we have in code. So y'all heard of Hello World, I'm assuming. It's basically the program everybody can write. It's really just as Hello World on the screen. Something you normally write on day one just to make sure you could do something. Do you think you could write that with no errors? I don't think you could. Could you ever write it so it would guarantee positively run on every system every time with no errors? You can't do that. You can't guarantee it's not going to conflict with something else. So I said there's normally 10 bugs in every 1,000 lines of code. It says Windows 10 contains over 50 million lines of code, has fewer than average bugs, but they still have them. There's bugs in everything. All right. Okay, C by Dennis Ritchie from 1972, Bell Labs. Originally written on Linux, or Unix, I'm sorry. First written in assembly language, later rewritten in C. C++ is an enhanced version of it. Okay. A compiler takes your source code, converts it into object code, or binary code like they say here, and then that is linked and make it into an executable. Programs like Java don't have an executable. They just have a class file that you run. The Java runtime environment runs that. So it says some C compilers can also create executable programs like C++, some can, some cannot. Okay, all right, there's C language. This is C. You got to import the standard IO library, then you call main. Normally you see int main, but I don't know why they don't have it on this case, but that's fine. And there's hello world. What's the /n do? New lines. Carriage return new line. Okay. Normally you'd write something like this in your first program. Comments normally start with asterisks and a slash there, or you could have a double slash or double quotes like in Python, or is it triple quotes? Triple quotes creates a comment in Python. You need parentheses in most languages. Like you have them in C. It's in pretty much everything. The main function is required, although sometimes it's not required. You need braces. Functions can call other functions, and they start talking about slash. None of this should be new to anybody yet. It's all pretty much basic. Okay. Variables are something we store things in. So it represents a numeric or string value. You must declare them before they can be used. There's a lot of different variable types. Okay, and yeah. So here we have int, float, double, char, string, constant. So a lot of different variable types. Depending on your operating system and language, some of these can hold different amounts of numbers or stuff like that. Operators, we have compare values. They can perform calculations. They have logical operators. We're going to look at a few of those. We're missing something. Okay, here we are. Declaring variables. They talk about unary. That's just not really declaring variables. I don't know why they put that there. These are mathematical operations. It's not declaring variables. I didn't put the title there. Okay. These are mathematical operations. We have a plus, we have a minus, we have a plus plus, plus plus increments, minus minus decrements. Then we also have modulus and division and multiplication and stuff like that. Nothing too new there. This is relational operators. Now, I don't know why it's still called declaring variables. It's not my fault. Okay, double equals means is it equal to? The explanation equals is not equal to. Then we have greater than, less than, greater than, equal to. Oh, I missed it. Okay. Less than or equal to is backwards. They got that one wrong. I don't know if you can see it there. And, or, and not. Yes, the same exact one. So, yeah, they got a lot of errors in these slides. Okay, but yeah, and, or, and not. Here's branching. We prompt for something. We can display something. You can call different. In this case, the main method is going to call the prompt, and it's going to call the display. Then you can call calculate and call cleanup. So you branch out and do different things. Here's a loop. While counter is less than 10, do something. In this case, it's printing out. Counter is equal to such and such. And if you ever want to play like with C and don't feel like finding your own compiler, thanks to William in the back corner, go to Replit, repl.it, an excellent place to compile and run C, C++, Java, Python. Let me show you what it looks like. It's actually very handy. I've actually used the heck out of it lately.
Use it a lot.
Yeah, it's really good. I'm not going to sign into it here, but you can get down here and you can say, you know what, I want to do some C++. And it literally even brings you up a sample program. So in this case, we're going to run Hello World, and I can literally just run it, and there you go. Pretty short and sweet. So I can go in and change this, put a couple more L's in there, and I don't have to worry about compiling. It literally does all for me. So very, very, very neat.
Send them that URL. That's the other neat thing about it.
Oh yeah, you can share the URL right here. No, this one right here. And you can actually see what I'm typing at this very moment, and you can actually get in and edit it. It's called Replit, repl.it.
Read, evaluate, process, something like that.
And then if you want a different language, just go down here and say, you know what, today I want to do, I don't know, let's do Python. We can do Python with Turtle. Oh, I didn't know they had one with Turtle. They didn't have Turtle on here, did they, last time?
Yeah.
Yeah, they did. They have the console and everything, so that's cool. But really nice place to use. And the cool thing is you set an account for free, and it will remember your stuff. So literally just keeps all your files up there. You can start a new one, and it's pretty darn handy. But yeah, those Ruby, PHP, regular Python, F#. Isn't that nice? Look at that. So then we could run it, and there's not really anything here to run, but so that's called Replit. So it's really a cool programming interface to use, especially if you want to just do some C or C++ real quick without having to find a compiler and install it and everything else. Okay. All right, here's GCC, which is a C compiler. Here you'll see they're compiling it. They're compiling while.c into the object while.o. Then they're taking that object while.o and making it into an executable while.e. Then they're running while.e on the third line. Okay, that's how they're doing. Yeah, exactly. So what happens is the C source code is compiled into the object. Then the object becomes the executable. Then you run the executable. Yeah, so pretty easy. All right, and this is a do loop, a for loop. Different languages support different kind of loops. Okay. Yes, or they're formatted differently, exactly. Like Python does not support a do while loop, but it does have a while loop. So Fortran has both. So
yeah, so they're both the same kind of loop. They're just formatted.
Yeah, exactly. Yes. Okay. And there's another one, a for loop there. There's an example there. HTML, in my opinion, HTML is not a programming language. Now HTML5 is. HTML really originally was just formatting. You would highlight some text and say make it bold or make it italics or underline it or do whatever. It's really a markup language. In other words, you mark up the text. You make it fancy. You make it pretty. Okay.
And then they added JavaScript.
Right. Then they added other stuff, and now with HTML5, you can pretty much do anything with it. Okay. Okay. A lot of times you need to examine web pages, recognize when something looks incorrect. And you can actually, let's go back to a web page here real quick. You should, if I remember right, this is just the page I was at. Yeah, where's the little bar up the top? There's normally the little bar at the top.
It's because there's an update, it's an exclamation point instead of
so
you can click it, it won't update as soon as you click it.
There you go, F12, you can actually see the JavaScript and the HTML that is putting out this page here. And it changes based on what's here. So kind of cool. You can actually follow the page source and see what's in there. You can click on it, and it is highlighting different stuff on the page.
You can also right-click on something on the web page and click Inspect Element or Inspect.
Right there, and go right to the Modules button right there, and there it is, the title Modules, which is a reference to course 2603 and modules. So it's kind of cool. If you didn't know you could do that, you can. Okay. Normally there's a little button over here. That's weird. Okay.
You can still click on it and it'll do the same thing.
Oh, okay, yeah. But wow. Oh, that's awesome. Then you go down here and you do, where is it? Inspect it. Element is not here. Who knows? F12 gets it up. Who knows? Okay.
Or inspect element.
So basic HTML says do not support branching, looping, but JavaScript does, and JavaScript does run on top of HTML. A lot of stuff is put inside the less than and greater than, denotes tags similar to this. HTML is, this is a starting tag, this would be an ending tag with a slash. And there's headers, there's page breaks, there's bold, there's italics, there's just all kinds of different formatting you can use. Here's what an actual page looks like. So it has a title, then it says page, bold, so it's making a page break. It's putting it in bold. There are many good web pages to visit for security testers, blah, blah, blah. Keeps going, then it ends the bold. Then it has a hypertext reference link right here, which is made red. So the word here would be red. And then the anchor, which is the /A, is the end of the hypertext anchor link. So pretty basic stuff there. And that's what it looks like. For some reason, they didn't put it in color. It's just stupid. They should have put it in color. That's the page it made. Okay. Perl. Perl is very similar to C. It's the practical extraction and report language. It was actually very popular. It was out way before Python. Okay. Power scripting languages, Perl and Python are two very popular languages. It's used a lot on Linux-based systems out there. Okay. Developed by Larry Wall in 1987. Works mainly on Linux, but it has been ported over with active state Perl. You can run Perl on Windows as well. So I ran it on my stuff. So hackers use Perl to automate exploits and do all kinds of other stuff. Okay, there's the version history of it. Okay, there's the -H, which is the help command, and then you have the print command right there. So there's, you just type Perl -H, so that's what it shows you. And you can see some of the capabilities. They don't really go into it very deep here. Now the format specifiers that you can use along with printf are the same for Java and C and Python and Perl. They're all the same. So if you know them on one, you know them on all. Yep, they're all the same.
When I was doing Java in high school, I never used those.
Oh, they're so
They
handy.
didn't tell us about this.
Right, because, I mean, printf. I mean, print stands for print with format. You can just do anything with it. It's so nice. Yeah, it's supported on all those languages. Okay. Rule syntax says the sub is like a sub function or a submodule is what they go with. Variable names start with the $. Commands or comments with the £, and the and indicates a function. So you kind of got to worry the way you name things in Perl. So for instance, there's our variables, there's our function. Wait, a function isn't it? That's an, isn't it? Yeah, function. And then there's our sub name. So this is defining our function, and this is the actual function down here. Okay, there's our loop. A for loop looks very similar to other languages. It's actually identical to Java. But Java, you cannot put a $sign in front of variable names. And there's our while loop, which is very similar as well. You just notice there's no semicolons at the end of the lines. Do they need them? Can't remember. Oh, well.
In the while loop, there was one.
Okay. I can't remember if they, you know, this might be off slightly. And here you see there are some semicolons. So I'm assuming like that print statement in the top of the loop probably needs a semicolon. Yeah, it has
The
to.
one at the bottom has one.
Yeah, so I'm
And
thinking
then
they just forgot to put it at the
Does
top.
the A++ need one?
Yes, it should have one as well. So, and there's testing conditions. There's an if statement again. Relational operators the same. The less than, greater than, so on and so forth. Even the equals are the same. Okay. There they show us most of the same things it did in the other language. Okay. It says technology changes frequently. Object-oriented program isn't new. It's been out for a very long time. But we do have languages like Visual Basic. Y'all seen Visual Basic lately? It's pretty much going away because we have things like C# now, which includes all the functionality of Visual Basic and C and Java and everything else. So it's been out for a long time. Might not be familiar to those just learning, but it is something easy to use. We have, with object-oriented, we have classes. And with C, you can use the double colon, which signifies a class from a function. So get employee is part of employee.
Java just uses a period.
Yeah. So it just depends on the language you're working with. Okay. There's an example there. And you know, there's some of their functions. There's a lot of built-in. I don't know why they put that in there. But what they're talking about is the Windows API. The Windows API is Application Programming Interface. Has a lot of capabilities built into it. And it's supposed to show it to you there, we just can't read it. Okay. Ruby. Ruby is very popular. That's what Metasploit currently runs on. It's an object-oriented. It's similar to Perl. It's okay, not near Python. It even says it. Metasploit has been rewritten to run on there. Okay. And there's an example of it. It's very simple to use. You can download Ruby and install it. It's also in Replit. It's like a sneeze. Works very nice.
That's just Metasploit.
This is Metasploit here. Yep, this is Metasploit. Yep. Okay. That's the end of program. We really didn't go into any of them very deep. So, but that's the end of the chapters. We just talked about all of them slightly. Any questions from anybody? Is anybody awake online still?
Yep.
All right. At least a couple of you are. That's good. All right. So, you know, you got assignments this week. And someone's alive. Yes, good. So you got assignments this week. Next week is your test. Then the following week is just a discussion. Don't miss out on the discussion. So many people are just skipping that.
Week after next is spring break.
Yes. You have to think about it with the discussions. Heck, even if you don't read the book, read other people's discussions and
Extrapolate.
I mean, exactly. Extrapolate something from them. Don't copy other people's.
Just copy paste.
All right, I'm going to stop the recording.